Chapter 4.3 here is pretty short. It is the differentiation of exponential functions. So we already showed that the derivative of e to the x is itself. It's e to the x. And we can use that fact and the chain rule to differentiate functions that are in the form y equals e to the gx, where g of x is any function. So we're going to be finding the derivative of functions e raised up to some other function instead of just x. So the way that we do this is the chain rule, and we actually did it at the end of the last section technically. So if we're doing the derivative of e to the g of x, e to a function, it's going to equal the derivative of the outer, leave the inside alone, times the derivative of the inner. So all you have to do is the derivative is going to be what you started with times the derivative of the exponent. And that's basically it. And for some reason, if you want to, you can rewrite it like this. The derivative of e to the u equals e to the u times the derivative of u with respect to x. You don't have to think about it like this right now. Just think about it like in terms of the first one. Okay, let's do a couple examples. Let's differentiate the following. So we want the derivative of e to the 5x. So this is going to be chain rule. You're going to essentially just rewrite what it is, multiply by the derivative of the exponent. So the derivative of 5x is just 5. So y prime is 5 times e to the 5x. And hopefully you get to the point where you can skip this step and you don't have to actually write that out. You can just do the derivative and just write it out. Okay, next one we have y equals e to the x squared minus 1. We want y prime. So the derivative is going to be e to the x squared minus 1. You start by just rewriting it out, times the derivative of the exponent, the derivative of x squared minus 1. So the derivative of x squared minus 1 is 2x minus 0. So the derivative here is 2x times e to the x squared minus 1. And you probably noticed that I typically write the e factor last. All right, next one, we have y equals e to the x minus 1 divided by x. So that's going to be y prime equals, we rewrite it, times the derivative of the exponent. And the derivative of the exponent here is actually chain rule. I'm going to do that on the side just so I don't run out of room. So quotient rule, sorry, that's quotient rule. Quotient rule here is going to be low d high minus high d low all over low squared. And if we simplify that, we get x minus x is 0. We actually get 1 over x squared. So we get 1 over x squared times e to the x minus 1 over x. So a little bit messier, but same exact concept. Okay, so basically just one more example here, and that's going to be using a couple differentiation rules with the chain rule that we just did to do a couple derivatives that can be a little bit harder. So for this, let's say that we have c and k are some numbers, just arbitrary constants. If we're doing the derivative of a constant times e to a constant times x, so c and k are just constants here, then the derivative is going to be the same thing that we kind of just did. You're going to rewrite it. It's going to end up being ce to the kx times the derivative of the exponent. The derivative of kx just equals k, for the same reason that like the derivative of 2x would just equal 2, because it's a linear term. Okay, so knowing that little shortcut is pretty nice, so let's go ahead and do that. It's technically nothing different than what we've just did. It's just a little bit simpler here. So let's differentiate this function, 3e to the 2x divided by 1 plus x squared. And that's going to be y prime equals, so we know that we need quotient rule. And that's going to be low d high. The derivative of the numerator is going to be 3e to the 2x times 2. So that's from the derivative of the exponent, minus high d low. The derivative of 1 plus x squared is 2x, all over low squared. So that's the hard part. Well, maybe the easy part. And then now we just have to simplify this. So simplifying this, first we get 6e to the 2x times 1 plus x squared minus 3e to the 2x, or minus 6xe to the 2x over that denominator. And this really doesn't simplify too nicely. I'm just going to do one more thing. In the numerator, I'm going to factor out a 6e to the 2x. And then what we would be left with is 1 plus x squared plus x over 1 plus x squared squared. And then maybe just the last thing that I would do in the numerator here is I would rewrite these parentheses so it's in the correct order in standard form. X squared plus x plus 1. Just put it in descending order. And that looks like as much as you can simplify. Okay, so that is it for 4.3.